Toyota makes per car due to its production process. Well, that's got the bosses at Toyota concerned, and here's how they're planning to solve the problem.
While you've been waiting for electric vehicles to become affordable, Toyota already made it happen, and nobody noticed. They just launched an electric SUV for $15,999, packed with artificial intelligence, autonomous driving features, and the demand was so intense it crashed Toyota's website. They received 10,000 orders within 1 hour. This is forcing automotive analysts to completely revise their market projections. But how did Toyota integrate advanced technology without premium pricing? What manufacturing strategies enabled this cost breakthrough? And why isn't this affordability available in your market yet? Don't go anywhere. This will shock you. The technology democracy revolution. How does an industry giant quietly revolutionize technology access without anyone noticing? The BZ3X packed advanced driver assistance systems, LiDAR sensors, and NVIDIA artificial intelligence processing into a vehicle priced below most gasoline-powered competitors. Toyota's engineering teams achieved something extraordinary, proving premium technology didn't require premium pricing. The vehicle featured 25 advanced driver assistance systems as standard equipment, features typically reserved for vehicles costing $40,000 or more. Families experienced autonomous parking, traffic jam assistance, and collision avoidance technology previously exclusive to luxury segments. The artificial intelligence integration represented an accessibility breakthrough. NVIDIA Drive AGX Orin X processing power, delivering 254 trillion operations per second, operated seamlessly within a $15,999 vehicle. This processing capability matched systems in vehicles costing 3 times the price. Momenta's 5.0 intelligent driving system provided software foundation, representing successful Chinese-Japanese technological collaboration. The system learned from real-world driving conditions, improving through experience rather than requiring expensive updates or service visits. Battery technology choices enabled dramatic cost reductions without sacrificing performance. 3 configurations spanning 50 kilowatt-hours to 67.9 kilowatt-hours provided range options, meeting diverse consumer needs. The base configuration delivered 430 kilometers of range, sufficient for daily driving requirements while maintaining affordability. Lithium iron phosphate battery chemistry proved crucial to cost breakthrough. These batteries offered enhanced safety characteristics, longer lifespan, and significantly lower costs compared to traditional lithium-ion configurations. The chemistry choice represented Toyota's commitment to practical innovation rather than theoretical advancement. The consequences would ripple across continents as every automaker realized their pricing assumptions had become obsolete. The manufacturing philosophy breakthrough. The middle class wasn't just squeezed, it was targeted. Toyota's strategy specifically addressed the gap between electric vehicle aspirations and financial reality, creating unprecedented accessibility without compromising technological advancement. The manufacturing approach revolutionized traditional automotive supply chain thinking. 65% Chinese supplier integration created localized production ecosystems that reduced costs while maintaining Toyota's legendary quality standards. This wasn't outsourcing, it was strategic partnership development benefiting all participants. Factory workers witnessed remarkable international collaboration that enhanced rather than threatened local employment. The GAC Toyota joint venture created opportunities for Chinese suppliers to develop expertise while providing Toyota cost advantages impossible through traditional importation. The ETNGA platform architecture specifically addressed electric vehicle requirements while optimizing manufacturing costs. Unlike converted gasoline vehicle platforms, this foundation was designed from inception to accommodate battery placement, weight distribution, and electric motor integration efficiently. Interior space optimization demonstrated thoughtful engineering priorities. Despite competitive exterior dimensions, the BZ3X provided nearly 3 meters of flat surface area when seats folded completely. This practical functionality addressed real consumer needs rather than pursuing aesthetic goals that compromised utility. Quality control methodologies applied Toyota's decades of manufacturing excellence to Chinese production facilities. The result proved affordability and reliability weren't mutually exclusive. They were achievable through intelligent design and strategic collaboration. Meanwhile, on factory floors across Detroit and Stuttgart, executives were studying every detail of Toyota's Chinese breakthrough. And look, we checked thousands of pages of technical specs, financial reports, and market data to explain how Toyota cracked the electric vehicle pricing code. You just learned in minutes what took automotive analysts months to figure out. Hit that subscribe button if you want us to keep uncovering these game-changing stories first. The market validation phenomenon. In just 24 hours, everything changed. The BZ3X's launch performance provided undeniable proof that affordable electric vehicles with premium features could dominate traditional luxury segments when priced appropriately. Sales managers experienced something unprecedented, watching month-long inventory disappear within hours of availability. The demand surge crashed not only digital systems, but fundamental assumptions about electric vehicle market segmentation and consumer behavior. Industry analysts scrambled to revise electric vehicle adoption projections. Previous models assumed gradual price reductions over multiple years as technology matured. Toyota's immediate breakthrough compressed these timelines dramatically, forcing complete recalculation of market development expectations. 6,030 units delivered in June 2025 alone demonstrated sustained demand beyond initial launch excitement. This wasn't curiosity purchasing. It represented genuine market acceptance of Toyota's value proposition and quality execution. The vehicle achieved top-selling foreign brand electric vehicle status in China's competitive market, remarkable considering domestic manufacturers' advantages in local market understanding and government support. This success proved superior value could overcome nationalistic preferences and established brand loyalties. Cumulative deliveries exceeding 20,000 units within 4 months established new benchmarks for joint venture electric vehicle success. These numbers represented real families making real purchasing decisions, not fleet sales or promotional programs inflating traditional automotive statistics. The numbers revealed something no one expected. This was just the beginning of Toyota's global affordability transformation. The artificial intelligence democratization. What if the biggest barrier to artificial intelligence adoption wasn't technology complexity, but pricing strategy? The BZ3X integrated NVIDIA's most advanced automotive processing platform into a vehicle costing less than half of typical artificial intelligence-equipped competitors. Engineering teams proved artificial intelligence could enhance affordable transportation without requiring premium pricing structures. The NVIDIA Drive AGX Orin X platform delivered computational power previously exclusive to vehicles costing $60,000 or more. Families suddenly accessed technology, making daily commutes safer, more convenient, and surprisingly enjoyable. The sensor array represented cost optimization mastery without performance compromise. 11 cameras, 12 ultrasonic sensors, 3 millimeter wave radars, and 1 LiDAR sensor provided comprehensive environmental awareness, matching luxury vehicle capabilities. This hardware integration enabled autonomous parking, traffic jam assistance, and collision avoidance, transforming ordinary driving into assisted experience. Momenta's partnership brought Chinese artificial intelligence leadership into automotive applications, creating end-to-end learning systems improving through real-world experience. The vehicle literally became smarter with use, adapting to individual driving patterns and local traffic conditions without requiring expensive software updates. Level 2 assisted driving capabilities operated seamlessly across all driving conditions, from congested urban traffic to highway cruising. The system handled lane changes, speed adjustments, and parking maneuvers with confidence, reducing driver stress while maintaining safety standards exceeding human-only operation. The artificial intelligence processing occurred locally rather than requiring cloud connectivity, ensuring privacy protection while maintaining response speed. This approach addressed consumer concerns about data security while delivering immediate performance-enhancing rather than complicating driving experience. Now, the entire artificial intelligence automotive industry hung in the balance as competitors realized advanced features couldn't justify premium pricing. The battery chemistry game changer. Your assumptions about electric vehicle costs? They just became obsolete. Lithium iron phosphate battery technology enabled Toyota to deliver competitive range at unprecedented price points while maintaining safety standards exceeding traditional lithium-ion configurations. Battery engineers achieved something extraordinary, proving safety and affordability could coexist without performance compromise. The chemistry choice eliminated thermal runaway risks plaguing earlier electric vehicle designs while providing cost advantages, enabling $15,999 pricing. The base configuration's 50.03 kilowatt-hour battery delivered 430 kilometers range under China's testing standards, sufficient for most consumers' weekly driving requirements. This range eliminated anxiety while maintaining affordability, making electric vehicle ownership accessible to middle-class families. Premium configurations extended range to 610 kilometers through 67.92 kilowatt-hour battery packs, addressing consumers requiring longer distance capability without compromising the vehicle's value proposition. composition. The chemistry remained consistent across configurations, ensuring reliability and service consistency regardless of trim level. Fire risk reduction represented crucial safety advancement, enhancing consumer confidence in electric vehicle technology. Unlike traditional lithium-ion batteries requiring complex cooling systems and fire suppression equipment, lithium iron phosphate chemistry provided inherent stability, simplifying vehicle design while improving safety. BYD's blade battery technology integration demonstrated successful cross-manufacturer collaboration, benefiting consumers through improved performance and reduced costs. This partnership approach created mutual advancement rather than competitive isolation, historically slowing automotive innovation. Across the ocean, Tesla engineers were analyzing every aspect of Toyota's battery breakthrough. The platform engineering revolution. What happened next would alter global automotive architecture forever. Toyota's ETNGA platform represented fundamental rethinking of electric vehicle construction, prioritizing affordability without sacrificing structural integrity or performance capabilities. Automotive engineers witnessed revolutionary modular architecture, enabling rapid cost optimization while maintaining structural rigidity essential for safety and handling. The platform integrated battery packs as structural elements rather than afterthoughts, creating weight distribution advantages, enhancing rather than compromising vehicle dynamics. The cross-framing structure transformed battery placement from liability into asset, using power storage systems to strengthen vehicle foundation while lowering center of gravity. This integration improved handling characteristics while reducing manufacturing complexity, traditionally increasing costs. Weight distribution engineering accounted for battery placement effects on handling, acceleration, and braking performance. The result achieved balance, making the vehicle feel lighter and more responsive than specifications suggested, creating driving enjoyment typically associated with much more expensive vehicles. The wheelbase measuring 2,765 millimeters optimized interior space while maintaining exterior dimensions, facilitating urban parking and maneuvering. This proportion balance addressed practical concerns without sacrificing passenger comfort or cargo capacity. Aluminum and high-tensile steel combination achieved strength-to-weight optimization, enhancing both performance and efficiency. Material choices demonstrated intelligent engineering, prioritizing function over cost-cutting while maintaining structural integrity essential for safety. Behind closed doors, Toyota's platform strategy was preparing for something much larger than Chinese market success: the connectivity ecosystem integration. How does traditional automotive thinking adapt to smartphone-native expectations? The BZ3X's 14.6-inch infotainment system and comprehensive connectivity represented Toyota's acknowledgement that vehicle technology must match consumer device sophistication. Technology users experienced seamless smartphone integration, exceeding expectations set by vehicles costing twice the price. The system responded to voice commands, gesture controls, and touch inputs, with responsiveness matching premium mobile devices while maintaining automotive-grade reliability and safety. The Qualcomm Snapdragon 8155 processor ensured performance, eliminating lag and frustration common in automotive infotainment systems. Applications launched instantly, navigation updated smoothly, and multimedia playback maintained quality, satisfying consumers accustomed to high-end electronics. The 8.8-inch digital instrument cluster provided customizable information presentation, adapting to individual driving needs and preferences. Drivers could prioritize range information, navigation guidance, or performance data without compromising safety or requiring attention away from road conditions. Over-the-air update capability ensured continuous feature enhancement and security improvements without requiring service appointments or manual intervention. The system downloaded and installed improvements automatically during parked periods, ensuring vehicles remained current with the latest functionality and security protocols. Voice recognition technology operated reliably across accents, languages, and ambient noise conditions, challenging lesser systems. The artificial intelligence processing enabled natural conversation rather than rigid command structures, frustrating users and limiting practical utility. What came next would test every traditional automotive company's ability to adapt to technology-first consumer expectations. The Tesla pricing strategy disruption. Tesla's premium positioning? It just became a liability. The BZ3X's feature-rich configuration at $15,999 forced every electric vehicle manufacturer to justify their pricing strategy against genuine value propositions, Tesla owners found themselves questioning fundamental assumptions about premium pricing and actual value delivery. The Model Y, commanding approximately $40,000 in the Chinese market, offered similar artificial intelligence capabilities, comparable charging speeds, and equivalent interior technology to Toyota's affordable alternative. The price differential no longer reflected meaningful performance or feature advantages. Potential electric vehicle buyers discovered affordable options, provided comparable technology without premium badge markup. The BZ3X delivered autonomous parking, traffic assistance, and smartphone integration matching Tesla's offerings, while adding features like LiDAR sensing and superior interior space utilization. Range comparisons revealed narrowing gaps, eliminating Tesla's traditional advantage. The BZ3X's 430 to 610 kilometer range options addressed most consumers' daily requirements while maintaining price points, making electric vehicle ownership accessible to middle-class families rather than early adopters with disposable income. Tesla's supercharger network, previously a decisive competitive advantage, lost significance as China's public charging infrastructure expanded rapidly. The BZ3X's compatibility with multiple charging standards provided flexibility, reducing dependence on proprietary networks while maintaining charging convenience. The disruption extended beyond pricing to fundamental questions about market segmentation. Tesla's strategy assumed consumers would pay premiums for electric vehicle technology and brand prestige. Toyota proved advanced electric vehicles could succeed through value delivery rather than exclusivity marketing. Deep within Tesla's Shanghai factory, executives were recalculating their entire Chinese market strategy. The BYD competition intensification. The decision didn't just challenge international competitors, it threatened domestic leaders. BYD's Yuan Plus, previously considered the affordable electric vehicle benchmark, suddenly faced direct competition from a joint venture offering superior technology at comparable pricing. BYD employees recognized their competitive advantage narrowing against an established automotive brand with international reputation and proven reliability. The Yuan Plus had succeeded through aggressive pricing and acceptable quality, but Toyota's entry raised standards while maintaining cost competitiveness. Chinese consumers found themselves comparing homegrown success against international expertise and reliability reputation. The BZ3X offered similar pricing to the Yuan Plus while providing superior artificial intelligence integration, better interior space utilization, and Toyota's legendary quality assurance. Technology feature comparisons revealed Toyota's artificial intelligence and connectivity advantages. While the Yuan Plus offered basic electric vehicle functionality, the BZ3X integrated NVIDIA processing, Momenta artificial intelligence, and comprehensive sensor arrays providing autonomous driving capabilities previously unavailable in the affordable segment. The partnership between Toyota and BYD for battery technology demonstrated collaborative rather than purely competitive approaches. BYD's Blade battery integration in the BZ3X created mutual benefit while establishing new standards for manufacturer cooperation in advancing electric vehicle technology. Market positioning evolved from domestic versus international competition to value versus premium segmentation. Consumers gained expanded choices, forcing all manufacturers to improve value propositions while maintaining profitability through efficiency rather than markup strategies. The entire Chinese electric vehicle ecosystem was about to experience unprecedented competitive pressure. The global manufacturer response crisis. When does innovation become an industry survival requirement? Toyota's Chinese success created immediate pressure on Volkswagen, Ford, General Motors, and every international manufacturer to justify their electric vehicle pricing and feature strategies. International automotive executives faced urgent board pressure to explain competitive positioning against Toyota's value breakthrough. Traditional pricing models relying on import premiums and brand positioning became indefensible when local production offered superior features at lower costs. Volkswagen's ID.3 and ID.4 experienced declining sales in the Chinese market following the BZ3X launch. European engineering and brand reputation couldn't overcome stark value differences when consumers compared feature lists against pricing structures. Engineering teams received emergency mandates to achieve Toyota's Toyota's cost-feature balance through rapid supply chain optimization and technology integration strategies. The urgency reflected recognition that competitive response required fundamental business model changes rather than incremental improvements. Manufacturing cost analysis revealed supplier integration advantages in the Chinese market weren't temporary or easily replicated. Toyota's 65% local sourcing created sustainable cost advantages, requiring fundamental supply chain restructuring to match. Joint venture partnerships became essential for cost competitiveness in the Chinese market. International manufacturers recognized success required local collaboration rather than importation strategies carrying unsustainable cost penalties. That's when international manufacturers realized Toyota had fundamentally changed the rules of global electric vehicle competition. The supply chain revolution catalyst. The automotive supply chain wasn't just disrupted, it was redesigned. Toyota's 65% Chinese supplier integration demonstrated that traditional global supply chains could be optimized for regional cost advantages without sacrificing quality or reliability. Supplier companies witnessed new partnership models creating mutual benefit through long-term collaboration rather than transactional relationships focused solely on cost reduction. The Toyota approach emphasized capability development, enhancing supplier expertise while reducing manufacturing costs. Manufacturing workers experienced increased local integration, creating employment opportunities while developing technical skills through international collaboration. The partnership model enhanced rather than threatened local capabilities through knowledge transfer and technology sharing. The 65% local sourcing versus typical international manufacturers' 20 to 30% integration demonstrated comprehensive supply chain localization, creating sustainable, competitive advantages. This integration required long-term commitment and partnership development rather than opportunistic cost reduction. Technology transfer and collaboration enabled mutual advancement, benefiting all participants rather than exploitation relationships creating dependency. Suppliers gained expertise and capabilities, while Toyota achieved cost optimization and supply chain resilience. 1% imported components demonstrated comprehensive domestic supply chain development, reducing complexity while enhancing cost competitiveness. This integration level required years of relationship building and capability development competitors couldn't replicate quickly. Now, every global automotive manufacturer faced a choice: adapt to regional integration or lose market competitiveness. The global market expansion strategy. What if China wasn't the destination, but the proving ground? Toyota's BZ3X success provided the blueprint for affordable electric vehicle deployment across emerging markets, where price sensitivity and feature requirements aligned with Chinese consumer preferences. International consumers in India, Southeast Asia, and Latin America watched China's electric vehicle revolution with anticipation that similar affordability might reach their markets. The BZ3X demonstrated advanced electric vehicles could achieve mass market pricing through strategic manufacturing and partnership approaches. Toyota executives developed expansion strategies based on successful Chinese manufacturing and pricing models, adapting to different regional requirements. The joint venture approach offered scalability potential, replicating cost advantages while respecting local market conditions and regulatory frameworks. Potential market analysis encompassed billions of consumers in price-sensitive regions where electric vehicle adoption depended on affordability rather than environmental consciousness or technology enthusiasm. These markets represented genuine volume opportunity rather than niche luxury segments. Manufacturing cost scalability studies indicated similar pricing could be achievable in multiple markets through appropriate partnership development and supply chain localization. The Chinese success provided proof of concept that cost optimization didn't require market-specific compromises. Regional customization requirements addressed different safety standards, emissions regulations, and infrastructure conditions without compromising fundamental value proposition. Toyota's experience adapting vehicles across global markets provided framework for electric vehicle expansion. Meanwhile, in boardrooms across Detroit, Stuttgart, and Tokyo, executives were studying Toyota's Chinese blueprint, the industry standard transformation. In just 24 hours, the definition of premium electric vehicles changed forever. The BZ3X's feature set at $15,999 established new baseline expectations, forcing every manufacturer to reconsider their value propositions. Consumers worldwide questioned why advanced features commanded premium pricing in their local markets when China demonstrated artificial intelligence, autonomous driving assistance, and comprehensive connectivity could be integrated affordably. The geographic pricing disparity became indefensible when technology capabilities were comparable. Automotive engineers recognized cost optimization and feature integration weren't mutually exclusive goals. The BZ3X proved advanced technology could be accessible through intelligent design and strategic partnerships rather than requiring premium pricing to justify development costs. Industry analysts revised electric vehicle adoption projections based on affordability breakthrough evidence, compressing traditional market development timelines. Previous models assumed gradual price reductions over years, but Toyota's immediate success demonstrated consumer demand existed at accessible price points. Feature standardization across price segments became consumer expectation rather than luxury differentiation. The BZ3X's comprehensive technology integration at $15,999 made basic electric vehicles without artificial intelligence assistance appear antiquated regardless of pricing. Technology democratization timeline acceleration resulted from competitive pressure, forcing rapid innovation rather than incremental improvement. Manufacturers could no longer justify extended development cycles when consumers could access advanced features immediately through strategic choices. The consequences would fundamentally reshape how the entire automotive industry approached electric vehicle development and pricing. The technology partnership evolution, traditional automotive hierarchies, they just became irrelevant. Toyota's success through partnerships with Chinese technology companies demonstrated that automotive excellence required collaboration rather than vertical integration or national industry isolation. The BZ3X represented more than just an affordable electric vehicle. It showcased how strategic partnerships could accelerate innovation while reducing costs and development timelines. Engineering teams discovered that international collaboration accelerated innovation beyond individual company capabilities while reducing development costs and timeline pressures. Toyota's partnership with Momenta for artificial intelligence systems, NVIDIA for processing power, and Huawei for connectivity solutions created synergies impossible through internal development alone. The partnership approach enabled specialization that created superior results compared to traditional automotive companies attempting to develop everything internally. Technology workers experienced cross-cultural knowledge transfer that enhanced expertise while creating innovative solutions impossible through isolated development. Chinese software engineers brought cutting-edge artificial intelligence experience, while Toyota's hardware specialists contributed decades of automotive reliability expertise. The collaboration model demonstrated that automotive advancement required diverse perspectives and complementary capabilities rather than single-company dominance. The partnership network encompassing Huawei, Xiaomi, Momenta, and NVIDIA represented global technology leadership integration that created competitive advantages impossible through internal development. Each partner contributed specialized expertise that enhanced overall system capability. Huawei provided telecommunications infrastructure knowledge, Xiaomi brought consumer electronics interface design, Momenta delivered autonomous driving algorithms, and NVIDIA supplied processing hardware, creating a comprehensive technology ecosystem. Development timeline compression through specialized collaboration rather than internal research and development investment enabled rapid market response to consumer needs and competitive pressure. Traditional automotive development cycles required 5 to 7 years for new vehicle platforms, but Toyota's partnership approach compressed this to less than 3 years while achieving superior technology integration. The approach demonstrated efficiency advantages that traditional automotive development methodologies couldn't match. Manufacturing partnerships extended beyond technology to include supply chain optimization that enabled the $15,999 price point. Local supplier integration reached 65% of components, creating cost advantages while building Chinese manufacturing capabilities. This collaborative approach contrasted sharply with traditional automotive companies that maintained centralized control over critical components and manufacturing processes. International collaboration became essential for competitive positioning rather than an optional advantage that could be pursued when convenient. The BZ3X success demonstrated that partnership strategies were fundamental requirements for electric vehicle market success in globally competitive environments. Companies attempting to maintain traditional vertical integration approaches found themselves disadvantaged against collaborative competitors. Quality control integration across partnership networks required Toyota to adapt its legendary manufacturing standards to collaborative environments. The company successfully transferred its quality methodologies to Chinese partners while learning new approaches to rapid iteration and consumer feedback integration. This mutual learning created stronger systems than either neither approach could achieve independently. Behind closed doors, Toyota's partnership strategy was preparing the foundation for something even more transformative: the economic paradigm revolution. How does one vehicle launch reshape global economic assumptions about transportation accessibility? The BZ3X's success provided concrete evidence that advanced electric vehicles could achieve mass market pricing without compromising quality, safety, or technological sophistication. The implications extended far beyond automotive markets to fundamental questions about economic development, environmental progress, and social equity. Economists recognized transportation cost reduction potential that could accelerate economic development in regions where mobility access determined employment and educational opportunities. The BZ3X demonstrated that electric vehicles could become economic enablers rather than luxury consumption categories. When transportation costs decreased, household spending could redirect toward education, healthcare, and economic development rather than mobility expenses. Environmental advocates witnessed affordable electric vehicle pathways to emissions reduction that didn't require government subsidies or consumer sacrifice. The market-driven approach proved that environmental benefits could align with economic advantages when proper engineering and partnership strategies were applied. This alignment suggested sustainable environmental progress could occur through market mechanisms rather than regulatory mandates or artificial incentive structures. Social equity specialists understood that technology access democratization could address transportation inequality that limited opportunity access for middle and lower income populations. The BZ3X pricing made electric vehicle ownership achievable for families previously excluded from advanced transportation technology. This accessibility could reshape social mobility patterns by removing transportation barriers to employment and educational opportunities. Toyota's breakthrough proves transportation transformation isn't just coming, it's here. Will this affordability revolution reach your market next? How will it change your transportation decisions? Drop your thoughts below. Smash that like button if this opened your eyes, and subscribe for more industry disruptions you need to know about. Thanks for watching.